we're going to use the same points as what I did in the previous little video. On point A is -102 and B is 032, and we actually calculate the area of this triangle, if you recall that. This question asks us to find a unit vector that's perpendicular to both, or to the triangle that's formed. So somehow in three-dimensional space we want to get a vector that's perpendicular to this surface, triangle 0A and formed by OA and OB. If we, same sort of sketch as before, we orientate our axes X, Y in their normal orientation, then Z coming out of the board or out of the paper. We've got, here's our triangle OAB, and we want to get a unit vector, not just any vector, but a unit vector that is perpendicular. We know that the cross product of OA crossed OB is the absolute value times the absolute value sine theta n. That's a scalar, that's a scalar, that is a scalar, and this is a vector, a unit vector, that is perpendicular to both OA and OB. Now it just happens that it would be, by using your right-hand rule for orientation, it would be a unit vector that is actually perpendicular to both those two vectors there, coming out, or actually going through that way. So if it's perpendicular at that point there, the vector will be perpendicular at any point on the triangle. So what we've got to do is firstly calculate the cross product. Now we did that in the previous one, so I'm not going to do that. So I think we got something like -6i plus 2j minus 3k. So when we calculated using the determinant of a matrix, this cross product, we got this as a vector. Now that's certainly a vector that is perpendicular to OA and OB, so if it's perpendicular to both those two lines, it must be perpendicular to the whole surface area the whole surface of triangle OAB. So here we got a vector. It is not a unit vector, so all we've got to do to actually calculate our vector, to find the unit vector, is to find, to express this as a unit vector. Now the way to do that is simply to write down as a vector and divide it by the magnitude of the vector. So the magnitude of the vector will be the square root of -6 squared plus 2 squared minus 3 plus -3 squared. And I think that turned out to be square root of 49.7, so it'll be -6i plus 2j minus 3k all over 7. Probably a better way to write it would be negative, if you want to write it in component forms, -6 on 7i plus 2 on 7j minus 3 on 7k. Now that is a unit vector, and it will be perpendicular to the triangle OAB, which fulfills the requirements of what we're asked to do. Incidentally, if you actually found the magnitude of that vector, you should get 1, because that's what a unit vector is.